substitution or substitution method for the integration. Now in the second part we will discuss about the integration using partial fraction. So second our method is your integration using partial fraction. Example. This example one I am taken that integrate 1 upon x square minus 9 with respect to x. Let I is equal to integration of dx upon x square minus 9, as we already know in the differentiation as well as in the previous this lecture, that with respect to x can be represented as dx. So dx upon x square minus 9. What is the factors of this x square minus 9? As we know that a square minus b square is equal to a minus b into a plus b. So a square minus 3 square is equal to a minus 3 into a plus 3. Here in this case, you just see that this 9 is the square root of 3. The square root of 9 is equal to 3. That's why I will write here 3 square, and it's a minus 3 and a plus 3. So this is written as dx upon x minus 3 and x plus 3. Now the question arises that how can I solve this question? I cannot rationalize because it is x square minus 9, and similarly it is very difficult to solve because we are not any standard form of the integration we can use directly this time, because we are just in initial stage of the integration. That's why I am using a partial fraction, one of the method of integration. So this is, I just use this partial fraction in the right hand side to solve this one, that how can we solve the problem with the help of this partial fraction. This is 1 upon x minus 3 into x plus 3. Here I have taken two constants. One constant is related with your x minus 3 and another constant I am taken as x plus 3. This x minus 3 and x plus 3, I am using now a simple. We can say that this is x plus 3 plus b x minus 3 upon x minus 3 into x plus 3, and that is 1 upon x minus 3 into x plus 3. And let's just take the LCM, and this LCM is ax plus 3 plus bx minus 3. Here this x minus 3 and x plus 3 is cancelled, and this is equal to 1 is equal to 8x plus 3 plus bx minus 3. There are two methods. In this situation, where take x plus 3 is equal to 0 and x minus 3 is equal to 0 separately and find the value. But it's also easy, there's no problem here. But I am just using the comparing the coefficients, and comparing the coefficients we find two equations, and because there are two constants, and using by any equation standard form or standard method and solve the question. Comparing coefficients of a and b, of x and constant. And when I am taken x is constant, so a plus b is equal to 0, that's your x, and 3a minus 3b is equal to 1, that's your constant value. This is my equation number 1, and this is your equation number 2. Here by substitution method, I am taken here b is equal to minus a. When I am taken b is equal to minus a, so 3a minus 3b this b is equal to minus a, so in place of b I will write here minus a, so this minus minus becomes plus. So 3a plus 3a is equal to 1. So 6a is equal to 1, so a is equal to 1 by 6. This is my first value of a is equal to 1 by 6. But what we suppose? B is equal to minus a. So b is equal to minus 1 by 6. Now this is b is equal to minus 1 by 6 and a is equal to 1 by 6. I just introduce again this 1 upon x minus 3 into x plus 3. A upon x minus 3 plus b upon x plus 3. In place of a and b, I write his values, numerical values 1 by 6 and minus 1 by 6, and therefore this is written as 1 by 6. This is the value of a, x minus 3 and dx minus, this is 1 by 6 dx upon x plus 3. As we know already, this is 1 by 6 and 1 by 6 are constant term. In the integration, we can just remove this out of this integration sign, and this is written as minus 1 by 6 integration of dx upon x plus 3. As we know that already, that dx upon x is equal to log of mod x, and therefore we can write log of x minus 3 minus 1 by 6 log of x plus 3 plus c, or this is written as 1 by 6 log of mod x minus 3 upon x plus 3 plus c, where log of m minus log of n is equal to log of m upon n. And therefore we can say here that this is equal to standard form. This is equal to log 1 by 6 log x minus 3 mod x minus 3 mod x plus 3, and c is our integrating constant we already explained.